found a way. All right, so this is like an easy lesson, but I feel like people don't get it. And maybe it's the way I explain it or something. But we're gonna do the area between two curves. So you have this curve, and then you have another curve, okay? And I want the area between them. How do you find the area between them? This is not hard. Are you ready? Mm-hmm. You're gonna take the area under this curve, so your upper curve, and then, you ready for this? You're gonna subtract the lower one. So if you have the upper curve and you subtract the lower curve, what are you left with? That area in between. Right? If you take this area and you subtract this area, you get that area. So the area under the curve, or between curves, is the integral from a to b of your upper function minus your lower function.
This is going to be a really big disappointment for you.
That's fine. I was expecting it. Not expecting you to be disappointed, but remember, like a 3 on the AP is a 36%.
No, but out of 45, we got like 15, right?
Yeah, that's fine. We'll get there. All right, so this is your formula. Sorry, I'm disappointed. Okay. What does upper mean? It means it has a higher y value. And what does lower mean? It has a lower y value. Now, some students get all tricked out, like if the function is up here, and then this one's down here. It's still upper minus lower. Why? Because the upper area is going to give you this part. And then if you subtract the lower, it's going to add this area. So like, don't get confused. It's just upper minus lower. Okay. So what does that require? It requires one thing. You have to have a good sketch, because you have to know which one is the upper and which one's the lower. Bad news, if you switch them, they'll just get a negative, and then you go, oh, I switched them. So like, they're very straightforward problems. However, sometimes they get tricky. So let's do a couple. I feel like they're straightforward, but then I say that and then they're, yeah. Okay, so we're gonna find the area of the region between the graphs f of x equals x squared plus 2 and g of x, which is negative x, on 0 to 1. Okay, first step, you're gonna make yourself a nice sketch. X squared plus 2 looks like this. Negative x looks like this. And we want the area between 0 and 1, which would be here. Can you go through? Okay, what's your upper function? It's either f or g.
Oh.
Which one's on top? F, right? So area is the integral, we have our bounds, 0 to 1, of f of x minus g of x. So this is x cubed over 3 plus 2x plus x squared over 2 from 0 to 1, which is 1/3 plus 2 plus 1/2, which is 5, 6. 2 and 5, 6, which is 17.6. Is that right? I went fast. Let's try another one. This one's harder because they do not give you the bounds. You have to find the bounds. So they want the area completely bounded by the graphs. Two minus x squared and negative x. We know what negative x looks like. 2 minus x squared, you go up 2. If x squared looks like this, negative x squared looks like that.
Upside down.
Now what's the problem? Well, the problem is that you don't have bounds. So you have to find your bound. How do I find these points?
I just have a past lesson.
It's like algebra 2, solved by graphing. Remember that? You guys remember those? They gave you the two equations of the line, and they were like, solved by graphing, and you were like, and you had to graph them perfectly and find where they met.
Oh, like the intersection.
Yeah. That would be horrible, right? So, number one, your calculator knows how to do it. You can just do second, calculate, and then go to intersect and find the two. Other way, and the better way, if you don't have a calculator, is you solve that,
So,
which we did in like pre-calc a million times, right? Substitution or elimination, then you go through all the, this one's gonna be what, elimination, so let's, yeah, substitution, I don't care. So, I'll substitute in negative x. So this looks like x squared minus x plus 2 equals 0, so this is x minus 2, x plus 1. So x equals 2 and x equals negative 1. Remember how you take this then and you plug it back in to find your y value. But you get a separate y value for each one. This makes a whole lot of sense now because we see the graph. Right, in pre-calc they just gave you that and you were like, why do I have 2 points? Now you're like, duh, I need 2 points to solve this problem. Do you have everything you need now?
Yes.
Area is the integral. What's the lowest x value you see?
Negative 1.
Negative 1. Highest x value you see? 2. What's the upper curve? Which one is a higher y value? Over here, the upper curve is negative x. But am I talking about over here? No, I don't even care about that. And I don't care over here. So what's the upper curve?
1.
2 minus x squared.
Okay.
What's my lower curve? Minus negative x. And you solve. Okay. Now, can you do this on your calculator? Sure. You can find the intersection points on your calculator. What you would want to do though is plug in this entire integral into your calculator rather than doing them separately.
Okay.
So you would plug in 2 minus x squared plus x and then integrate from negative 1 to 2. Rather than plugging in 2 minus x squared, finding the area, and then subtracting manually, because there's a lot of error there. So,